Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics Chapter 2 Work, Energy, Power. We will be discussing the topics units and measurements of work, energy and power. Plus, we will be doing some problems related to this. Are you ready? Let's begin. What is work? I am teaching. Okay, I am a teacher and I am teaching. Am I doing work? Here you can see a teacher. A boy is studying. Is he doing work? Here we have another boy who is pushing a car. Is he doing work? In our day-to-day life, we come across many instances where work is said to be done. But according to science, every one of this cannot be considered as work. Then let's see what is work according to science. Here I have a pen in my hand. I am throwing this pen and catching. What have I done? I have applied a force on this pen. Now take these examples. Here you can see a batsman who is hitting a ball. Then you have a boy who is pushing a car. Apple is falling down from a tree. Then you have a boy who is pulling a cart and a boy who is pushing a wall. Take all these instances. We'll see if there is work done or not. Is force applied in all these cases? Here you can see force is applied by a batsman on the ball. Here the boy is applying a force on the car. Then in this case, gravity is pulling apple down. Okay, there is force. Gravitational force is there. Here this boy is pulling the cart. There is force. And what about this? You can see this boy is already tired, which means he has applied force. So in all these cases, force is being applied. Even when I have thrown this pen upwards, what have I done? I have applied a force on this pen, right? So in these cases, force is applied. What about the change in the object? Is there any change brought to this object? You know, force is any push or pull. Okay, force is being applied. Is there any change? There should be some change either in the state of rest or in the state of motion. Then shape, size, etc. Here the ball will start moving. What about this? The apple is falling. Here the boy is pushing the car but the car is not moving. Take these cases. Is the wall moving? Wall is not moving. Here when the boy pulls the cart starts moving. Okay, let's see if work is done or not. Now we can define work as work is said to be done only when the force applied on a body makes the body move. That is, there is a displacement of the body. Two elements, that is, work is said to be done only when there is a force and there is a displacement. If any of this is absent, then there is no work done. Okay, now consider the examples we have taken previously. First case, apple falling. When an apple falls down, is there force? Yes, there is force. There is force of gravity. Earth is pulling apple down, which means earth is applying a force. Okay, there is force. Now what about displacement? Is there displacement? Initially the apple was on the tree. Later, apple falls to the ground, which means from tree it has displaced to the ground. There is displacement. Okay, the position has changed. Next, pushing a wall. We have seen an example where a boy is pushing a wall. In this case, is there force applied? The boy is getting tired, right? The force is being applied by the boy. What about displacement? When you push a wall, just go try this. When you push a wall, is there any displacement? Is the wall getting displaced? No, right? There is no displacement. Okay. Third example, pulling a cart. When a boy pulls a cart, force is being applied. We know any push or pull is called a force. Force is applied. What about displacement? There is displacement. In the direction in which force is applied, the body is moving. Here the cart is moving. There is displacement. What about pushing a car? While pushing a car, a boy is pushing a car. What is happening? Force is applied? Yes, force is applied. What about displacement? Car is not getting displaced. No displacement. Okay. Hitting a cricket ball. Hitting. Force is being applied. Okay. What about the position of cricket ball? Is it changing? Is it getting displaced? Yes, it is getting displaced. So in these cases, in some cases, there is only force. In some cases, there is both force and displacement. Now tell me, in which cases work is said to be done? Work done. Is work done in all these cases? All these 5 examples is work said to be done? No, right? Okay. In the first case, that is apple falling, is work done? Yes, work is said to be done. Why? Because there is a force and there is a displacement. Next, second case, pushing a wall. Pushing a wall. Force is there, but there is no displacement. Therefore, there is no work done. Work is not said to be done. Next is pulling a cart. Pulling a cart, there is force and there is displacement. There is work done. What about pushing car? There is force, but there is no displacement. No work done. Hitting a cricket ball, force is being applied and there is displacement. Therefore, there is work done. Only in 3 cases, that is out of the examples we have taken, only in 3 cases we can say work is done. That is apple falling, pulling a cart and hitting cricket ball. In other 2 cases, there is no displacement and hence work is not said to be done. Okay. Next is measurement of work. How to measure work? We said that work depends on 2 factors. One is force and the second is displacement. Okay. Work depends on force and displacement. Work is said to be done only if there is both force and displacement. If any of these elements is absent, then work is not said to be done. Consider a case. We have 2 bodies and 2 forces are being applied on the bodies to displace them through 5 meter distance. Okay. First body is being displaced by 5 meter. Let us say take the displacement as S. And the second body is also displaced by 5 meter. Displacement S. Okay. Now here the force applied is F1 and here the force applied is F2. F1 force is applied on the first body to move it through a distance of 5 meter. The body is getting displaced through 5 meter. Okay. Second body is also displaced through 5 meter, but what is the difference? Here the force applied is F2. Now I am telling that F1 is greater than F2. Okay. The first force is greater than second force. Okay. In this case, there is difference in work done also. Work done will be more if the force is more. When force increases, work done also increases. Okay. Now consider another case. That is, we have 2 bodies and the same force F is being applied on both the bodies. First body gets displaced through a distance of 5 meter. This displacement we are taking as S1. Second body gets displaced through a distance of 10 meter which we are taking as S2. Okay. Here the displacement S2 is greater than S1. Same force is applied, but the displacement is greater in the second case. Therefore, work done will be greater in the second case. Okay. Amount of work done depends on 2 factors. What are the factors? First one, magnitude of force applied, and the second is displacement produced by the force. Okay. When force increases, work done increases, or if displacement increases, work done increases. Both force and displacement increases, work done increases. Understood? Now, the amount of work done by a force is equal to the product of force and the displacement of the point of application of the force in the direction of force. Work done depends on force and displacement. Work done is the product of force and displacement. Okay. If a 10 Newton force displaces a body through 5 meters. Okay. Force of 10 Newton displaces a body through a distance of 5 meter, then work done. Tell me what is the work done? Work done is force into displacement, which is 10 Newton into 5 meter. Okay, that is 50 Newton meter. Clear? 50 Newton meter. We will be studying other units of work done as well. Clear? And this work done is a scalar quantity. We know force is a vector quantity. Displacement is a scalar quantity. But work done is a scalar quantity. Okay. Expression for work. We have studied that work depends on force and displacement. Work is equal to force into displacement. How? Force should be applied and the displacement should be in a direction that is in the direction of force applied. Now take this case. We have an inclined plane. Okay, a box is to be moved from here to here, that is from point A to point C along an inclined plane. The plane is inclined with an angle theta. Clear? Now, you see the force applied. This is how the force is being applied. This is the direction of force. So, displacement should also be in the same direction. But here you can see displacement is along this slope. Okay, to get the displacement here, you will have to take the horizontal component. Now, you can see when you have an angle theta here, we can take the horizontal component and the vertical component. This is ABC. Okay, for this angle theta, you will have sine theta. What is sine theta? Sine theta will be opposite side divided by hypotenuse. Here it is BC divided by AC. What about cos theta? Cos theta will be equal to adjacent side by hypotenuse. Here the adjacent side is AB. Hypotenuse is AC. What about tan theta? Tan theta is opposite by adjacent. BC divided by AB. Now in order to get the horizontal component, we need this base, right? To get the base, that is AB, either you will be using this cos theta or tan theta. Now we know the displacement is S. So this is how the body is displaced along the horizontal slope. That is, here the hypotenuse of the right triangle consider. Okay, this is the hypotenuse. Here we have displacement. So displacement should be included. Displacement is included here. That is, we have displacement AC, which is S. Cos theta is equal to AB by AC. We can take this in order to get AB. AB will give the horizontal component of the angle theta. Okay, horizontal component of displacement is AB. Clear? We have work is equal to force into displacement. In this case, force is taken as F. F force is applied in this direction. Displacement, we have to take the cos component. Here we have cos theta is equal to AB divided by AC. Okay, that is, since cos theta is equal to AB divided by AC, AB by, what is AC? AC is the displacement, we can take it as S, which means we will be having AB is equal to S cos theta. AB will be equal to S cos theta. Okay, here force into displacement, displacement is AB. Work will be F into, what is AB? S cos theta. Okay. Therefore, work is equal to Fs cos theta. Okay. Force is applied and the displacement along the direction of force. Okay. So, this is the equation. We need to take the force, magnitude of displacement and the cosine of angle between the force and displacement vectors. We know force and displacement are vectors. We have to take the angle theta between, the cosine of the angle theta between force and displacement. Therefore, work is equal to force into component of displacement in the direction of force. Here this force is being applied in this direction and the component of displacement is a cos component of displacement along the direction of force. Okay, that is W is equal to Fs cos theta. Got it? Here we have taken the component of displacement in the direction of force, that is by finding the component of displacement along the force. Okay, next is finding the expression for work by finding the component of force along the displacement. In the previous case, we have taken the component of displacement along the direction of force. Here, consider this figure. PA is the direction in which the force is applied. Magnitude F, force of magnitude F is being applied. PA is the direction. Okay, what is the direction of displacement? Displacement is in this direction. So, we need to take the component of force in this direction, that is along the slope at an angle theta. Now, when you extend this line, you will be getting NA. Okay, we have taken NA by extending this line AC. AC is the displacement. We have work is equal to force into displacement. Here displacement is the same, that is AC. Force. Force, we need the component of force that is in the direction of displacement. That is, here it is NA. Okay, NA. Now, we will be considering a right triangle. Here, by extending this, we understand that we have two vertically opposite angles, right? This angle and this angle will be equal. They are vertically opposite angles. So, PAN will be equal to theta. Now, we will take the cos component. What is cos theta? cos theta will be equal to adjacent. Adjacent is NA divided by hypotenuse. Here we have the right angle, which means hypotenuse is PA. PA is the force. Okay, therefore cos theta is equal to NA divided by force, and then NA is equal to F cos theta. Okay, NA is the component of force along the direction of displacement. Now substitute what is NA? NA is equal to F cos theta, cos component of force, into AC. AC is the displacement, that is S. Work W is equal to F cos theta into S, that is the component of force in the direction of displacement into displacement. Work is equal to component of force in the direction of displacement into displacement. W is equal to F cos theta into S. Same answer we are getting. There you got F into S cos theta. Here it is F cos theta into S. That is, we can write it as W is equal to Fs cos theta. Therefore, work depends on the angle between the force and displacement vectors. Clear? Force and displacement are vectors. It is not only on the magnitude of force and displacement that work depends. It also depends on the angle theta. Clear? Next, we are going to study how to find work done by plotting graphs. Work done by variable force and constant force. Two types of forces, that is variable force and constant force. We are going to plot graph and find the work done. First case is variable force. What is variable force? That is, there is change in displacement with change in force. When force changes, displacement also changes. That is what variable force is. That is, force is changing. Okay. Now take a case. Here a body is moving with different forces. Okay. Then the displacement will also change. Now at different instance we are going to plot graph. Here along the x-axis we will be taking displacement. Okay. And along the y-axis we are going to take force. Force along the y-axis and displacement along the x-axis. Now initially the body starts moving, that is force is being applied. When force was applied, there is a displacement. Okay, you get a point here. Again, more force is applied, more displacement is made. Force is being increased, displacement is increasing. So this is how it goes. Okay, when you join these points, you will be getting a straight line that is inclined to the x-axis or the displacement axis. Now, from this point, draw a perpendicular. Okay, you draw a perpendicular. Now, in order to calculate the work done, here we have plotted a graph between displacement and force. In order to calculate the work done, what we have to take is we have to find the area of this triangle. Here we have a right triangle. By finding the area of the right triangle, we can get the work done. Here work done is equal to area of triangle. Okay, what is area of triangle? W is equal to half into base into height. Okay, here this is base and this is height. Yes, here we have the base and this is the height. Base is the displacement. From a point 0, it has moved to a point, say, B. Origin to B. Okay, so OB is your base, that is displacement. Here we have force. Let's say a force of F is being applied here. Okay, into F. Here work done will be half into displacement into the force. Okay, half into the component of displacement into force. This will be giving you the area. Area is the work done. Clear? Next case is with constant force. A constant force is applied and what is the displacement? Again, plotting graph, displacement you have here and force along this. Okay, when force is applied, there will be displacement. Constant force is applied, which means here at every point displacement, that is say 1 meter, 2 meter, 3 meter, 4 meter, at every point, whatever be the displacement, force will be the same, which means we will be getting a straight line parallel to the x-axis or displacement axis. So, drawing a perpendicular, you will be getting a rectangle. Finding the area of this rectangle. Okay, finding the area of this rectangle, you will be getting the required work done. Work done is equal to area. In this case, it is the displacement into force. Okay, displacement into force will be giving you the work done. Clear? In case of variable force, it is half into displacement into force. That is the area of triangle. In case of constant force, it is the area of the rectangle. Okay, there are three types of work done. One is positive work done, second is zero work done, and third is negative work done. Let's see what they are. First is positive work done. If the displacement is in the direction of force, that is theta is equal to 0 degree, then cos theta is equal to 0 and work done will be positive. Consider this example. Here we can see a boy is pulling a cart. In which direction is the force applied? This is the direction in which force is being applied. What about the displacement? Here there is a basket of toys. In which direction is it moving? It is moving in the same direction in which force is applied. Now if this boy is pushing this car, okay, pushing this basket, what happens? Pushing. Direction of force applied will be in this direction and the displacement will also be in the same direction. So in this case, we say that work done will be positive. Here what is the angle between them? Angle between the force applied and the displacement. They are parallel to each other, right? They are in the same direction, which means theta, angle theta will be equal to 0 degrees. Okay, theta will be equal to 0 degrees. We have expression work done W is equal to Fs cos theta, where theta is the angle between force and displacement. Okay, now force. Here force and displacement are parallel to each other. Angle theta is equal to 0 degrees. Okay, Fs cos 0. Angle is 0. What is the value of cos 0? Cos 0 is equal to 1. Therefore, work done W is equal to Fs into 1. W is equal to Fs. Okay. Work done is the product of magnitude of force and displacement. Consider another example. Here I have a pen in my hand and I am dropping it down. Okay. In which direction was the force applied? To drop the pen, force is applied downwards. What about displacement? In which direction is the body moving? Pen has fallen down, which means it is also moving downwards. Here force is acting downwards and the displacement is also downwards. What is the angle theta? Angle theta, they are parallel to each other. Theta will be equal to 0. Cos theta equal to cos 0, which is 1. Therefore, we will be having work done W is equal to Fs into 1, which is Fs. Okay, work done W is force into displacement, magnitude of force and displacement. Understood what is positive work done? Just remember, force and displacement will be in the same direction. Okay. Next is zero work done. If a force acts on a body and the body does not move, that is displacement is 0, then the work done is 0. Okay. Here consider this case. A boy is pushing the wall. While pushing the wall, he is applying force. Is there any displacement? No displacement, right? So, when displacement is equal to 0, then work done W is equal to F into S, and that will be equal to force into 0 displacement, which is 0. So, work done is said to be 0 or 0 work done when there is no displacement. This is one case. Now, the second case is when the displacement is normal to the direction of force. Normal means what is the angle? 90 degree. When theta is equal to 90 degree, then cos theta will be cos 90 degree, which is equal to 0. Now consider this case. Here we have a girl who has tied a stone to a string and the stone is in uniform circular motion. We have studied in the previous chapter, a body will be in circular motion only when there is a centripetal force. The centripetal force helps a body to move in a circular motion. Okay, so body is in circular motion, there is centripetal force. In which direction is this force acting? Force is acting towards the center. What is the direction of displacement of the body? We know that at every point, the body will be having a direction of displacement in this direction, that is tangential. Okay, in the tangential direction it will be having a tendency to move. So once this girl leaves the string, what happens, or the string breaks, what happens, the body will be moving tangentially. Okay, at every point you will be able to draw a tangent to the circle. We know that here this string is a radius to the circle. Okay, radius and tangent will be having an angle of 90 degree between them. That is, radius and tangent will be perpendicular to each other. Okay, the angle between them is equal to 90 degree, which means that it is normal. Force applied is normal to the direction of motion. Angle is equal to 90 degree. Okay, when theta is equal to 90 degree, we need to find work done. Fs cos 90 degree. What is cos 90 degree? Fs into cos 90 degree value is equal to 0. Therefore, work done W will be equal to 0. So, work done is 0. So, two cases will be getting work done 0 or 0 work done. The first case is when there is no displacement, when displacement is equal to 0. Second case is depending on the angle theta, when the angle between force and displacement is equal to 90 degree. Force and displacement is perpendicular to each other. In both these cases, we will be getting work done 0. Okay. So, we know that work done depends on force, displacement and angle between the force and displacement. Either force should be 0 for work done to be 0, or the displacement should be 0, or the angle between force and displacement should be 90 degree. Okay, we'll take another example. Here I am holding a book in my hand and I am moving forward. Consider this case. In which direction is the force being acting? The book will always be applying a force towards the ground. Okay, force of gravity will be acting. In which direction is the motion of the body? Here the book is moving in the forward direction. This direction, right? Book is applying a force towards the ground, that is downwards. Force is being applied downwards by the book, but the body is moving in the forward direction. Now the angle between them is equal to 90 degree. So this is again a case where we say that the work done is equal to 0. Since the angle between the force and the displacement is equal to 90 degree, they are normal or perpendicular to each other, we say that work done will be equal to 0. Okay. Next is negative work done. What is negative work done? If displacement is in the direction opposite to the force, that is theta is equal to 180 degree, then cos 180 degree is equal to minus 1. In that case, we call the work done is negative. Okay, here in opposite direction, what does that mean? Now, consider this case. I have a pen in my hand, I am throwing it up. What happened? The body is being moving in a direction that is opposite to the direction in which the force of gravity is acting. Force is acting downwards. Okay, force of gravity is acting downwards, but the pen, when it moves up, displacement is in the opposite direction. Then what is the angle between the force and displacement? What is theta? Theta is equal to 180 degree. They are parallel but opposite in direction. Theta will be equal to 180 degree. That is, force is applied in one direction and displacement is in opposite direction. When theta is equal to 180 degree, what is cos theta? What is cos of 180 degree? Cos of 180 degree is equal to minus 1. Correct. Minus 1. Okay. We have work is equal to Fs cos theta. Work is equal to Fs into cos theta minus 1. Work is minus Fs, which means the work done is negative. Consider all these cases. Here you can see a boy moving with books in his hand. Okay. The books will be applying a force in the downward direction. Force of gravity is in downward direction. In which directions is the book moving? He is climbing the stairs, which means the books are moving in a direction opposite to the direction in which force is being acting. Force is acting downwards, displacement is in opposite direction. So, in this case, when you consider force of gravity, we can say the work done is negative work done. Okay, now take this case. Here a girl is throwing a ball upwards, which means the force of gravity will be acting down. The ball will be pulled by gravity downwards. weight of the ball or force of gravity is acting. Force is in this direction. Ball is moving in opposite direction. Displacement is in the direction that is upwards, which means here again the work done is negative. Take this case. Here the boy is pulling the rope. In which direction is he applying force? He is applying force downward direction. When he applies a force in the downward direction, the bucket will be rising, right? Bucket will be rising. That is, displacement of the bucket is in opposite direction. Again, force and displacement are at an angle of 180 degree. They are in opposite direction. Therefore, the work done will be negative work done. Understood what positive work done, zero work done, and negative work done is? In case of positive work done, cos theta, cos 0 will be equal to 1. In case of 0 work done, cos 90 degree is equal to 0. The work done will be 0. In case of negative work done, cos 180 degree is the angle. Cos 180 degree is minus 1. Therefore, we will be getting work minus Fs. Clear? Next is work done by force of gravity. So, work done by force of gravity. We know that every object is attracted towards the center of earth by force of gravity or weight of our body. Any object will be attracted to the center of earth. So, here you can see an apple falling. Why is it falling? Because the force of gravity is acting. A body of mass m, when it falls, what happens? It is traveling through a distance h. Okay. It is traveling a height h to reach the ground. Now here we know that work is equal to force into displacement. Okay. In which direction is the force acting? To find the work done by force of gravity, in which direction is the force acting? Force is acting downwards. Force of gravity will always be acting downwards. Why? Because every object is pulled down. Okay. So here this mass is being pulled by the force of gravity and the force of gravity F is acting down. Now we know that force depends on mass and acceleration. Here what is acceleration? Acceleration is acceleration due to gravity, that is m into g. Okay, m into g, a body of mass m, it's moving with an acceleration g, that is 9.8 meter per second square. Clear? Which is the weight of the body. Force mg is equal to weight of the body. Here mg is the force. Now what is the displacement? It is traveling through a distance of h. It is moving through a height h, which means displacement is h. So, in this case, work done will be mgh. Okay. Because of the force of gravity, there is a work done. For this apple to fall, or when I am dropping a ball, what is happening? The earth is attracting with the force of gravity. The work done by force of gravity, W is equal to mgh, where m is mass, g is acceleration due to gravity. The value of g, 9.8 meter per second square. And h is the height through which it has travelled. In this case, this is the distance travelled and this is the required height. Okay, this case is when the body is moving in the same direction of force applied. Force is applied downwards and the body gets displaced downwards. Now take another case. When you are throwing a ball up, in which direction is the ball moving? Ball will be moving in this direction, that is upward. Okay, so here we have a body of mass m, a ball of mass m, which is moving upward. In which direction is force of gravity acting? Force of gravity will always pull it down. Okay, force of gravity will always be in the downward direction, which means the body is moving in a direction that is opposite to the direction in which force is applied. Okay, in that case, the work done will be negative. Here we got mgh, body of mass m. Mass cannot be negative. Then you have acceleration due to gravity. It can be negative. Okay, g can be negative and h. So here minus mgh is the work done. So it is not necessary that the work done, the force is along a stairs or along a slope or along a lift. It can be any case. Okay, work done by gravity is same whether the body comes down from a certain height using stair, slope or lift. Force of gravity will be same. Consider an inclined plane. This is an inclined plane. When the body reaches here, force of gravity will be in this direction. When the body reaches here, force of gravity is downward direction. It never changes. Okay, force of gravity will always be acting downwards. It doesn't matter whether if it is a stairs or a slope or a lift. Okay, understood? So it can be positive or negative when in the same direction, force and displacement are in the same direction, work will be mgh, which is positive. When the body is moving in a direction opposite to the direction in which force of gravity acts, then work will be negative. Clear? Next, what are the units of work? We studied work is force into displacement. Work is equal to force into displacement. Okay. To find the unit, force. The unit of force is Newton and displacement is meter. Therefore, Newton meter is a unit of work, but there is a standard unit, that is the SI unit. SI unit of work is Joule. Okay. Joule, small letter J, and the representation, it is represented as capital J. Clear? And what is 1 Joule? Here we understand that when do we get 1 Joule of work? When 1 Newton of force is applied to displace a body through a distance of 1 meter. If a force of 1 Newton displaces a body through a distance of 1 meter, then the work done is said to be 1 Joule. 1 Joule of work is said to be done when a force of 1 Newton displaces a body through a distance of 1 meter in its own direction. Direction is important. In which direction force is applied? The displacement should also be in the same direction. So, got the SI unit. There are some other units also. First is just kilojoule. We know if we consider distance, you have meter as the standard unit, then kilometer, then you have centimeter, you have millimeter, decimeter, nanometer, etc. So, in case of work also we have different units. First it is a kilojoule. Kilo means anyway the power will be 10 raised to 3. 10 raised to 3 joules is kilojoule. Next is megajoule, mj, it is represented as mj, which is 10 raised to 6. Mega means 10 raised to 6. 10 raised to 6 joules, and gigajoules, gj, which is 10 raised to 9 joules. So these are bigger units, okay. Bigger units of work done. Then you also have smaller units. Before that, what is CGS unit? The CGS means centimeter, centigrams and seconds. So CGS units is erg. Erg is the CGS unit. So 1 erg. What is 1 erg? 1 erg will be equal to 1 dyne into 1 centimeter. Here, dyne is a unit of force. When force is in Newton and displacement is in meter, you will be getting joules. Joules will be the unit of work done. When force is given in dyne, 1 dyne, and displacement is in centimeter, then you will be expressing it in CGS unit, which is 1 erg. So 1 erg will be equal to 1 dyne into 1 centimeter. Understood? When force is applied, is the unit of force is dyne and that of displacement is centimeter, then the CGS unit should be taken, which is 1 erg. Okay. Now 1 erg of work is said to be done when a force of 1 dyne displaces a body through a distance of 1 centimeter in its own direction. So got the units of work? Clear? Next, let us see what is the relationship between joule and erg. We have 1 joule. We have work is equal to force into displacement. Okay. What is the unit of work? Joules. So when you take 1 joule of work, 1 joule of work is when 1 Newton force displaces a body through a distance of 1 meter. Okay. Now, force is expressed in newtons. So 1 Newton is actually equal to 10 raised to 5 dyne. Okay, dyne is also a unit of force. Then displacement here it is expressed in meters. Displacement is 1 meter. Okay, 1 meter, how many centimeters? 100 centimeters. 1 meter is 100 centimeters. So displacement taken in centimeter and force taken in dyne will be giving you work in erg. Okay. So here 1 joule is equal to 1 Newton is 10 raised to 5 dyne into 1 meter is 100 centimeter into 100 centimeter, which means 1 joule is equal to 10 raised to 5. Here we have 2 more zeros, that is 10 raised to 2. 10 raised to 5, 10 raised to 2, that is 10 raised to 5 plus 2, which is 10 raised to 7 dyne centimeter. So, dyne centimeter is erg. We will be getting 10 raised to 7 erg. Okay. So this is a relation between joules and erg. 1 joule is equal to 10 raised to 7 erg. Clear? Got the relation? Let us take an example. A crane pulls up a car of mass 500 kg to a vertical height of 4 meter. Calculate the work done by the crane. Okay, so the crane is pulling a car vertically upwards. It has moved through a distance of 4 meter. Now, in this case, tell me what is the force. In order to find work done, we need force and displacement. Work done is the product of force and displacement. Work done is the product of force and displacement. Now, what is the force? Here, the force will be acting downwards because due to the force of gravity, earth pulls every body towards its center. Okay, due to the force of gravity, the weight of the body, that is the weight of the car, is the force in this case. Force will be equal to weight. Okay, what is weight? Weight is mass into acceleration due to gravity. Mass into acceleration due to gravity. We know weight is equal to mg. M into g. What is the value of g? Acceleration due to gravity, g is equal to 9.8 meter per second square. Okay, mass is given in the question, which is 500 kg. M is equal to 500 kg. Now tell me what is the weight, that is the force in this case. Force is equal to mass into acceleration due to gravity. 500 into 9.8, which is equal to 4,900 Newton. Newton is the unit of force. We have studied in the previous chapter. 4,900 Newton is the force that we are getting. Now we can easily find the work done. W is equal to force into displacement, which is 4,900 into, what is the displacement? Displacement of 4 meter. 4. Okay, so you will be getting 4,900 into 4, which is 19,600, and the unit of work. When force is in Newton and displacement is in meter, you will be getting work done in joules. Okay, 19,600 joules, or if you have to convert it into a bigger unit, you will be getting 19.6 kilojoules. This is not necessary, just I have given you 19.6 kilojoule is the work done. Okay, let's take another example. A force of 10 Newton displaces a body by a distance of 2 meter at an angle 60 degree to its own direction. Find the amount of work done. Very simple, right? What is work done? Work done, W is equal to Fs cos theta. Here the angle theta is given. Theta is equal to 60 degree. Then what is cos theta? Cos theta will be cos of 60 degree, which is equal to 1 by 2. Okay. Now, force is given. Force F of 10 Newton. And the displacement is given. Displacement of 2 meter. Work done, W is equal to Fs cos theta. Force is 10. Displacement is 2. Cos of angle 60 degree. Okay, that is 10 into 2 into cos 60 degree is equal to 1 by 2. 1 by 2. 2 and 2 gets cancelled. Then the answer is 10. What is the unit? Joules. 10 joules is the work done. Okay, this is a direct question. Force is given, displacement is given, and the angle theta is also given. We just need to substitute the values to get work. Remember, you should know the values, that is cos values. Cos 0, that is basic angles. Cos 0, cos 30, cos 45, cos 60 and cos 90. At least this you have to know. Next, we are going to study about power. What is power? Power is the rate of doing work. Okay, and power is a scalar quantity. Here, power is something that depends on work and on another factor, which is time. Okay. If a person is able to complete a given amount of work in a small time, you will be saying that he is more powerful. For example, let's take 10 joules of work is done by 2 people, A and B. Okay, A does this work in just 5 minutes. B takes 10 minutes. Then who is more powerful? Yes, A will be more powerful. That is, when time decreases, work done increases. Okay. In less time, if a person is able to complete, then we say that he is more powerful. Power spent by a source depends on two factors. First one is the amount of work done by the source. And the second, the time taken by the source to do the work. Okay. Now we have a relation. Power is equal to. Power, we said it depends on work. Okay. When work increases, work done increases, power also increases. And the second factor is on time. We said that when time increases, power decreases. Okay. This case, 10 minutes, the time has increased, which means the power has decreased. Okay. Therefore, power and time is inversely proportional. Power is equal to work done divided by time taken. Okay. Power is work done divided by time taken. So, one relation is P is equal to W divided by T, where W is the work done and T is the time taken. We have work done W is equal to force into displacement. Okay, force into displacement is work done. W is equal to F into S. Okay, in this place of work done, we can substitute Fs. Okay, P is equal to F into S divided by T. We have studied velocity. V is equal to, what is velocity? Velocity is the rate of change of displacement. Displacement divided by time. Displacement by time gives velocity. Here we have displacement and time. Displacement by time is velocity. Therefore, we have a relation power is equal to force into velocity. Okay. Power is equal to work by time and power is also equal to force into velocity. Okay. When velocity increases, power increases. When force increases, power increases. Okay. This is a relation which shows power, force, velocity relation. Okay. Understood? Next, what are the units of power? We have studied the units of work done. Okay, the SI unit of power is what? What is power? We have power is equal to work done divided by time taken. Okay. Work done unit is joules and that of time is seconds. Joule per second is a possible unit, but from the name of a scientist, we have taken the SI unit of power, which is watt, and it is represented as capital W. Now, when do we say the power is 1 watt? When do we get 1 watt power? 1 watt power is when 1 joule of work is done for 1 second. Okay, 1 by 1 we get 1. Therefore, 1 watt. 1 watt is equal to 1 joule by 1 second. That is, if 1 joule of work is done in 1 second, the power spent is said to be 1 watt. When do we get 1 watt? We get 1 watt when 1 joule of work is done for 1 second. Clear? Then we have some bigger units and smaller units. The bigger units, like we have for grams. Gram, the bigger unit is kilogram. Then for meter, you have kilometer. Similarly, for power, we have kilowatt. What is kilo? Kilo means 10 raised to 3. Okay. Kilowatt is 10 raised to 3 watts. Megawatts, MW is 10 raised to 6 watts. And then gigawatts, 10 raised to 9 watts. Okay. 10 raised to 3 kilo, 10 raised to 6 mega, 10 raised to 9 giga. Now, the smaller units, two smaller units we have to study. One is milliwatt and the other is microwatt. Milli, 10 raised to minus 3. Milli means 10 raised to minus 3. So, 1 milliwatt will be equal to 10 raised to minus 3 watts. And 1 microwatt is represented like this. This is a symbol to represent micro. Microwatt is equal to 10 raised to minus 6 watts. So, we have studied the SI unit and 5 other units of power. Okay. Now, what is the CGS unit of power? We have studied the CGS unit of work, right? Power is equal to work divided by time. So, when it comes to SI unit, work is expressed in joules and time is in seconds. So, power is watt. 1 watt is 1 joule per 1 second. Okay. Now, when it comes to CGS unit, we know 1 joule is equal to 10 raised to 7 erg. So, 1 watt will be 10 raised to 7 erg per Time is expressed in second itself. So in CGS, centimeter, grams and seconds. So second is a CGS unit, 1 second. So 10 raised to 7 erg second inverse. So this is the unit. So 1 watt will be equal to 1 joule per second, which is 10 raised to 7 erg second inverse. Okay, then we have a higher unit, that is a bigger unit, which is used mainly in mechanical engineering purposes, that is horsepower. 1 horsepower will be equal to 746 watt. We know 1 kilowatt is equal to 1000 watts. Then what is 1 watt? 1 watt will be 1 by 1000 kilowatt. Here 1 horsepower is 746 watt. What is 746 watt then? 746 divided by 1000 kilowatt, which is equal to, taking decimals, 0.746 kilowatt. Therefore, 1 horsepower is 746 watts or 0.746 kilowatts. Got it? We have discussed the CGS unit and horsepower. Clear? Let us take an example related to power. Calculate the power of an engine required to lift 10 raised to 5 kg of coal per hour for a mine 360 meter deep. Here acceleration due to gravity should be taken as 10 meter per second square. What is power? How to find power? We have power is equal to work done divided by time taken. Now in this case, we have to first find work done. Time taken. 10 raised to 5 kg of coal per hour. Per hour means time taken will be equal to, T is equal to 1 hour. 1 hour should be converted into seconds. Okay. That is 1 hour will be equal to 60 minutes and 60 minutes is equal to 60 into 60 seconds. 60 into 60 seconds. Hope you all know how we get this. 1 hour is 60 minutes and 1 minute is equal to 60 seconds. Okay. Then what is 60 minutes? 1 hour is equal to 60 minutes, that is equal to 60 into 60 seconds. 60 into 60 is 3600. 3600 seconds is the time taken. Now we have to find work done. To get work done, we know work done is force into displacement. Displacement is also given. It is lifted through a height of 360 meter. S is equal to 360 meters. Here force will be equal to mg. Okay, because it is the weight of the body. Body is being lifted against gravity, mg. M is 10 raised to 5 and acceleration due to gravity is 10. Next, work will be equal to force into displacement, which is 10 raised to 5 into 10 into displacement is 360 meter. That is the height. Now we can find power. Power P is equal to work done divided by time taken. Here the work done is 10 raised to 5 into 10 into 360 divided by the time taken. Time taken is 3600 seconds. Okay, zeros can be cancelled. 36 cancel. Then we have 10 raised to 5. What is the unit? Here mass is in kilogram. Acceleration due to gravity is in meter per second square. Then time is taken in seconds. Then the power unit should be the standard unit. That is the SI unit, which is watts. 10 raised to 5 watts is your answer. What are the differences between work and power? We have studied about work and also we have studied about power. We know power depends on work. What are the main differences? The first difference, this is just the simple definition of each work. Work done by a force is equal to the product of force and displacement in the direction of force. We have work is equal to force into displacement. Okay. What about power? What is power? Power is the rate of doing work, or power of a source is the rate of work done by the source. We have power is equal to work done divided by time taken. Okay. Next difference is work done does not depend on time. It doesn't depend on time. What are the factors on which work done depends? Work done depends on force and displacement. There is no role for time here. What about power? Power spent depends on the time in which work is done. Work by time is power. When time increases, power decreases. Power and time are inversely proportional. So, work does not depend on time, whereas power depends on time. Now the third is just the SI unit of each. SI unit of work is joules and the SI unit of power is watts. Okay, so these are the basic differences between work and power. We have studied about work and power. Next topic is energy. What is energy? Energy is nothing but energy is actually the work done. Energy depends on work done. And we say that energy of a body is its capacity to do work. Do we actually need to explain energy? We know that if you have good amount of food, then you will be healthy and you will be energetic, you will be able to do more work. That is, work done increases when energy increases. Now, when work is done on a body, then the energy of the body increases. If work is done by a body, in that case, energy decreases. That is also clear. Okay, we know that work is a scalar quantity, power is also a scalar quantity, and hence energy is also a scalar quantity. That is, what is the work that we are getting, same is the energy, and the unit also will be discussing will be same as that of work done. Okay, what that is, when work is done by a body, then energy decreases. When work is done on the body, then energy increases. Just these are the basic things you need to know about energy. We'll discuss the units of energy. The SI unit of energy is same as the SI unit of work done. SI unit of energy is joule, represented as capital J, and the CGS unit is erg. 1 joule will be equal to 10 raised to 7 erg. Okay. Now there are two other units. Before that, we can find energy. Energy power relation, that is, energy is equal to power into time. So we have studied a relation. What is power? Power is equal to work done divided by time taken. We said that work done and energy are the same. So cross multiplying, we get work done is equal to power into time. Same. Energy is equal to power into time. From this, we have two other units. First is watt hour. Watt is the unit of power and hour is the unit of time. Okay. 1 watt hour, represented as 1 WH, is the energy spent or work done by a source of power 1 watt in 1 hours. When power is 1 watt and time taken is 1 hour, then the energy is represented as 1 watt hour. 1 watt hour is another unit. Okay. 1 joules. Similarly, another unit is 1 watt hours. Okay. Joules is when the time is in seconds and power is in watts. Next is kilowatt hour. Kilowatt hour is a bigger unit. Kilowatt. Kilowatt is a unit of power when power is in 1 kilowatt. 1 kilowatt hour, 1 kWh, is the energy spent or work done by a source of power 1 kilowatt in 1 hours. Okay. So when power is 1 kilowatt and time taken is 1 hour, then this is equal to 1 kilowatt hour of work done or 1 kilowatt hour energy. Clear? So for joules, joules is equal to, here power will be in watts but time will be in seconds. So 1 watt hour and 1 joule is not the same. 1 joules is when 1 watt of power is in 1 second. Okay, there is difference. Understood? Let's take an example. We have to express 5 kilowatt hours into joules. Okay, 5 kilowatt hours into joules. How to express? What is 1 kilowatt hour? 1 kilowatt hour is equal to 1 kilowatt power into 1 hours. We have to convert into joules. Joules is equivalent to watts second. Okay, watts second. So here 1 kilowatt is 1000 watts and 1 hour is equal to 3600 seconds. Okay, 1 kilowatt is 1000 watts and 1 hour is 3600 seconds. So 1 kilowatt hour, how much do we get? Will be equal to 3.6 into 10 raised to number of zeros 1, 2, 3, 1, 2, 3, 6. 10 raised to 6 watt second. 3.6 into 10 raised to 6 watt seconds is 1 kilowatt hour. How much do we need? We need 5 kilowatt hour. This watt second will be equal to joules. Okay, that is the SI unit. 3.6 into 10 raised to 6 joules. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. Now we need 5 kilowatt hour. How to get 5 kilowatt hour? 5 into 1 kilowatt hour, which is 5 into 3.6 into 10 raised to 6 joules, that is equal to 5 into 3.6 is 1.8 into 10. Now this 10 and 10 raised to 6 when multiplied, we get 10 raised to 7 joules. Okay, 5 kilowatt hour is equal to 1.8 into 10 raised to 7 joules. If you are asked to find 2 kilowatt hour, we know 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. 2 kilowatt hour will be equal to 2 into 3.6 into 10 raised to 6 joules. Okay. So understood how to convert kilowatt hours into joules. Next unit of energy is calorie. Calorie, heat energy. Mainly in case of heat energy, we will be using this unit of calorie. Is usually measured in calorie. Okay. So what is 1 calorie? If you have 1 gram of water, to rise the temperature of 1 gram of this water by a temperature of 1 degree Celsius, it is called 1 calorie. 1 calorie is the heat energy which is required in raising the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius, or through 1 degree Celsius. That is, the temperature should rise by 1 degree Celsius. The amount of energy that is required to raise the temperature of 1 gram of water. Take 1 gram of water and raise the temperature by 1 degree Celsius. How much energy is used is called 1 calorie. Okay. So 1 joule is 0.24 calorie. If 1 joule is 0.24 calorie, you can express 1 calorie as 4.18 joules. How you are getting this? If 1 joule is equal to 0.24 calorie, then 1 calorie will be equal to 1 divided by 0.24 joules. When you take 1 divided by 0.24, you will be getting 4.18 joules. Therefore, 1 calorie is 4.18 joules. Next, a bigger unit, which is kilocalorie. Kilo means 10 raised to 3. 1 kilocalorie will be 1000 calories, which is 1000 into 4.18. You will be getting 4180 joules. Understood what calorie and kilocalorie is? It's mainly used in case of heat energy. Okay, you have one more unit to study, which is electron volt. It is in case of atomic particles. Okay, the energy transfer in case of atomic particles is very small, so it is measured in electron volts. So this unit is used in case of atomic particles. The previous, in case of heat energy, we use the unit calorie. What is 1 electron volt? When you have an electron and you have to accelerate this electron by providing a potential difference of 1 volt. 1 electron volt is the energy that is gained by an electron when it is accelerated through a potential difference of 1 volt. This is what 1 electron volt is. 1 electron volt is equal to charge on an electron into the potential difference, that here it is 1 volt. Okay, what is charge on an electron? We have studied about electrons. What is the charge of an electron? 1.6 into 10 raised to minus 19 coulomb. Okay, into 1 volt. This is what 1 electron volt is. Okay, that is 1.6 into 10 raised to minus 19 coulomb into volt will give you joules. Okay, it is an energy, that is charge and potential difference. Clear? So 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. This is the relation between electron volt and joule. We have studied the relation between the electron volts and joule, and also between joules and calories. Okay, you will have to convert it into cases. If in a question, if energy is given in electron volt, you should know how to convert it into joules. If it is given in calories, you should know how to convert it into joules. So that is why you will have to study these relations. Clear? Let us try an example. The energy of an electron is 4.0 into 10 raised to minus 19 joules. Express it in electron volt. What is the relation? We have 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. Okay, this is the relation between electron volt and joules. Now what is given? Energy is given. Energy is equal to 4.0 into 10 raised to minus 19 joules. Okay, this much joules is given. We have 1 electron volt is this much joules. Okay, then what is 4.0 into 10 raised to minus 19 joules in electron volts? How to find? Tell me. Let's take this as some x electron volt. Okay, x electron volt is equal to 4.0 into 10 raised to minus 19 joules. 1 electron volt is 1.6 into 10 raised to minus 19 joules. X electron volt, that is we are taking a ratio which is 4.0 into 10 raised to minus 19 joules. To get what X is, X electron volt will be cross multiplying. Taking this to the opposite side, you will be getting 4.0 into 10 raised to minus 19 divided by 1.6 into 10 raised to minus 19. Okay, joule is the unit. Joules can be cancelled. 10 raised to minus 19 can be cancelled. What is 4.0 divided by 1.6? 4.0 by 1.6, you will be getting 2.5 electron volt. X value is equal to 2.5. Therefore, you will have 4.0 into 10 raised to minus 19 joule is equal to 2.5 electron volt. Clear? Just you have to do the division. Next, the differences between energy and power. We have studied the differences between work and power. Next is energy and power. Energy and work are same. We have said this. So, energy and power. First thing is the definition. Energy of a body is its capacity to do work. Next, define the power here. Power of a source is the rate at which energy is supplied by it. So, there we have define power in terms of work, rate of doing work. Here it is related to energy. Power of a source is the rate at which energy is supplied by it. Okay. Next, energy spent does not depend on time. We know that work does not depend on time. Therefore, energy spent also does not depend on time. Whereas power depends on time. Power will be energy by time. Power depends on the time in which energy is spent. Next is the SI unit. SI unit of energy is joules. What about the SI unit of power? SI unit of power is watts. So, these are the basic differences between energy and power. First thing, you have to just define it. Now, remember, when there is a comparison between energy and power, define power in terms of energy. First problem, a body when acted upon by a force of 10 kgf gets displaced by 0.5 meter. Calculate the work done by the force when the displacement is, first case, in the direction of force at an angle 60 degree with the force and normal to the force. Take G is equal to 10 Newton per kilogram. Okay, here we have force is equal to mass into acceleration. When it comes to acceleration due to gravity, F is equal to mg. Then G will be equal to F by m, from which we are getting this unit, which is Newton per kilogram. Force expressed in Newton and mass expressed in kilograms. So, Newton per kilogram is taken as a unit for G. Okay, 10 Newton per kilogram. Now, we have a force which is 10 kgf. Okay, so here G is 10 Newton per kilogram, which means you will be getting 1 kgf is equal to 10 Newton. Okay, here we have 10 kgf, which is 10 into 10 Newton, that is 100 Newton. Force is 100 Newton. Okay, force is 100 Newton. In the first case, the displacement is in the direction of force. Then what is theta? Theta will be equal to, tell me. Yes, there is 0 angle. Force and displacement are along the same direction. Then theta is equal to 0. Displacement is given 0.5 meter. S is equal to 0.5 meter. Now what is work? Work is Fs cos theta, that is force 100 Newton into displacement 0.5 meter into cos 0. What is cos 0? Cos 0 is equal to 1. 100 into 0.5 into 1, which is equal to 50. What is the unit? Work. Unit of work is joules. 50 joules. You will be getting 50 joules. Okay. Now the second one. At an angle of 60 degree with the force. So angle between force and displacement is 60 degree. Theta is equal to 60 degree. Here again force is the same, that is 100 Newton. Force is 100 Newton. Displacement is also same, that is 0.5 meter. Work is equal to Fs cos theta. Work is force 100 into displacement 0.5 cos of 60 degree. What is cos 60 degree? 1 by 2. Correct. So 100 into 0.5 into 1 by 2. Okay, that is 100 into 0.5 into 1 by 2 is again 0.5. 100 into 0.5 into 0.5, you will be getting 0.25. 0.25. 0.25 into 100, what do we get? 25. Correct. So work is 25 joules. 25 joules. Now the third case. Normal to the force. So if force is in this direction and displacement is in this direction, then the angle between them will be equal to 90 degree. They are perpendicular to each other, force and displacement. Okay, here theta is 90 degree. Normal means angle theta is 90 degree. Force is same, that is 100 Newton. Displacement is same, 0.5 meter. Then work is equal to Fs cos theta. Work is equal to 100 into S, 0.5 into cos theta. Theta angle is 90 degree. What is cos 90 degree? 0. Correct. So 100 into 0.5 into 0, which means the work done will be 0 joules. There is no work done. You know this, right? We have studied 0 work done is when force and displacement are perpendicular to each other. That is theta is equal to 90 degree. Clear? Next, the second problem. A weightlifter lifted a load of 200 kg force to a height of 2.5 meter in 5 seconds. Calculate first one the work done and the second the power developed by him. We have to take G is equal to 10 Newton per kilogram. Here the weightlifter is lifting a weight through a height of 2.5 meter. Then what is the displacement? Displacement will be equal to 2.5 meter. Okay. What is given? The weight is given, which means the force is given. Force F is equal to 200 kg force. Okay. Given that G is equal to 10 Newton per kilogram, which means this is equivalent to 200 into 10 Newton. Okay. G, here the kilogram and kilogram will get cancelled, then you have in Newton. 200 into 10, which is 2000 Newton. Force is equal to 2000 Newton. What else is given? Displacement is given. S is 2.5 meter. Then tell me what is work? Work is force into displacement. Force and displacement are along the same direction. That is, the weight is being lifted upwards, force is applied and the body is moving upwards in the same direction. Okay, angle between them theta will be equal to 0. F is 2000 into 2.5. 2.5 into 2000 is 5000 joules. Work is equal to 5000 joules. Okay, we got the work done. Now we have to find power. What is power? Power is equal to work divided by time. Rate of doing work is power. Okay, here P is equal to, what is the work? Work we have determined, which is 5000 joules. 5000 divided by time. Time is given 5 seconds. 5000 by 5 is 1000. What is the unit of power? Watts. Okay. 1000 watts is the power that is developed by him. Clear? Third problem, an ox can apply a maximum force of 1000 Newton. It is taking part in a cart race and is able to pull the cart at a constant speed of 30 meter per second. While making its effort, calculate the power developed by the horse. We have to calculate power. What are given in this question? Force is given. Force F is equal to 1000 Newton. Do we have displacement? No displacement is given. We have a speed given, which is velocity, is 30 meter per second. Now how to determine power? We have power is equal to work by time. Okay. Work is force into displacement divided by time. Okay. Now force into displacement by time. This can be written like this. What is displacement by time? Displacement by time is velocity, which means power is equal to force into velocity. Just substitute the values. Force is given 1000 Newton and velocity is 30 meter per second. Therefore, the power is equal to 30 into 1000, which is 30,000. 30,000 watts, or it can be expressed with a bigger unit, that is 30 kilowatt. Power is 30 kilowatt. Very simple, right? You have to know this relation, that is power is equal to force into velocity. Even if you don't know, you can just derive it. That's all for today. In today's class, we have discussed about work, energy and power. We have discussed the different units of energy, power and work, and also we have solved some questions from exercise 2A. There are a few more questions which you can solve on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.